All right, so we're in the middle of section 4.1 on divisibility, and we are on example 4. Does that sound right? All right. Last time we established quite a few different divisibility rules, and we also looked at some, like in example 3 last time, where there wasn't a rule, but we had some other facets that we could look at and make decisions about using some of the stuff from chapter 3. And so we're going to kind of explore a little bit more in that direction on the next example. Example 4 says, if 24 divides some number m, capital M, what other numbers must divide m? So if something is divisible by 24, what else would it be divisible by? 2 would be one of them, you bet. How do you know?
The number in the ones place ends in 0 to 3.
Okay, let me ask the question a little bit differently, Hannah. That's how we decide if a number is divisible by 2. How do you know the number would be divisible by 2 if all you know is that it's divisible by 24? Let's maybe think about it for a moment. What's a number that's divisible by 24? 24 itself would be 1. What else? 48 would be 1. 72. Do you know what the next one is? It is 96. All right, we'll pause there. So one way to think about it, to kind of answer my question to you, Hannah, would be to look at those numbers, right? Generate sort of the list of numbers that we have and think about those numbers. If you did, you'd notice these all happen to be even, right? Now, there's a reason behind why they're even, but you can look at these numbers and tell that. So, yes, they will be divisible by 2. What else are they all divisible by? 3. And we had a test for doing that. Do you remember that test, Becca?
Is it just the last two?
Nope. That was the test for 4.
Add them together?
Where you add them together. That's the one where you add all the numbers together to decide. What other number is this going to be divisible by 2 and 3 and 6 would work? There's a number before 6. 4 will work. And 6. 8 will work. But how in the world do you know that 8's going to work? You're looking at my list of numbers still, right? Has anybody figured out what the common denominator is between what all these numbers have in common with the one I started with? They're factors. This number is 24. If a number is divisible by 24, then it's divisible by all the factors of 24. And we're not quite finished listing them, but we've gotten a good start. 2, 3, 4, 6, 8, 12. And we're actually done then, right? Because anything bigger than 12 won't divide 24. I mean, 24 will, but we already know it's divisible by 24. You could also say 1. I mean, 1 divides everything, so if we want to be really complete with my list, 1 would be included. It's not real exciting, but... So in order to decide, let's say we wanted to decide if a number was divisible by 20, what would we have? 1, 2, 4, 5, and 10, right? So we're just looking for all the factors of the number itself. If it's divisible by some bigger number, it's going to be divisible by all the factors of that number. Okay. And it's very much for the same reason why when we looked at this last time, part D down here, that this worked. How do we know that 2 times 3 times 5 times 7 is divisible by 5? Because 5 is a factor, right? I can break it down and I can write it that way. Well, if it's divisible by 24, it's going to be divisible by all the factors because it can be factored down in that way. What about example 5? Example 5 says, what numbers could go in the blank so that the following number is divisible by, and these are 3 parts. Part A, the number 2. What number would have to be able to go in the blank so that I'd have a number divisible by 2? An even number. So can you give me a list? Right. So any of those numbers go in that blank, I've got a number divisible by 2. How about part B? What numbers could go in that blank to give me a number divisible by 3? And or how could you figure it out? Okay, so what did you get when you added them all together?
Oh, just kidding. I thought it would be
It's okay. Did somebody add them together? Did you get 16?
Yeah.
Okay. So you guys are adding these together to get 16. Is 16 divisible by 3? No. So I can't put a 0 in the last blank. That won't work. Can I put a 1 there? 2 could go there, though. Right? Because 16 plus 2 would be 18, and 18 is divisible by 3. What else could go in that blank? 5. Because 16 plus 5 is 21. Good. How about 8? 8 plus 16 would be 24. Yes, 24, and 24 is divisible by 3. How could I decide what numbers would need to go in the blank so that it's divisible by 6? The numbers that these two lists have that are the same or have in common. So what do you see that they have in common? 2 and 8. So either of those numbers in that blank will have the number be divisible by 6. And we talked about last time, if it's divisible by 6, it's divisible by 2 and 3. And if it's divisible by 2 and 3, it's divisible by 6. And do you remember what I called 2 and 3? Their relationship to one another? Because we're going to see it again in section 4.2. Relatively prime. They don't have anything in common with each other. That's why this works. Okay? All right, let's try another one. Example 6. Answer the following and justify your answer. If a number is divisible by 5, can it be divisible by 10? So could it be? Can it be? Is it possible? Yeah, it's possible. And an example of such number would be what? Can you give me one? 20, sure, 20. So 20 is divisible by 5, so 5 divides 20. Remember that notation from last time? We read it 5 divides 20, and 10 also divides 20. Okay, so can it be? Yes. Does it have to be? No. And if you wanted to give me an example of that, what could you give me an example of? 15 would work, right? Okay, so the operative word here is the word can. All right, next question says, if a number is divisible by 10, can it be divisible by 5? Oh, I'm sorry, I read it wrong. Thank you. If a number is not divisible by 10, can it be divisible by 5? Yes. For example, 15. So 10 does not divide 15, but 5 does divide 15, doesn't it? It's good information. Does it have to be? No. So can you give me an example where this would all fall apart? An example where it doesn't have to be divisible by 5. A number that is not divisible by 10, that is not divisible by 5. 8, thank you. So 8 does not, it doesn't divide by 10, right? There's lots of examples. 8 does not divide by 10, and it also does not divide by 5. We're just trying to find an example where, because again, the word we're focusing on here is the word can. Can it be? Not does it have to be. Because if we change that word from can to has to or must, then this all doesn't work anymore. So. All right, last one. A number in which each digit except 0 appears 3 times is divisible by 3. For example, 777, 555, 222, and 414, 143, 313, that is, all the numbers appear there 3 times, are divisible by 3. Explain why this is true.
Because if it's multiplied by 3, then it has to be able to be divided by 3. Because like 3 times 7 is 21, 5 times 3 is 15, 2 times 3 is 6.
Okay, so I'm going to use the example you're using, this one right here, okay? So in the number 777, 555, 222, we have 3 numbers that match. 7 plus 7 plus 7, which is just 3 times 7, right? And we can do that for all the numbers. 5 plus 5 plus 5 is 3 times 5. And 2 plus 2 plus 2 is 3 times 2. So Hannah's exactly right. They all have a multiple of 3 with them, don't they? It's a factor of 3 in each of them, so they are all multiples of 3, which means they're all divisible by 3. Okay? So each, in fact, you know what, I can even do this. How about this? If I were to add all of these together, I would have 3 times 7 plus 3 times 5 plus 3 times 2. And I'm about to do something just scary. You ready? I'm going to take a 3 out. I undistributed the 3, didn't I? It's one of your properties, right? Distribution from chapter 3 was so this has a factor of 3. So the sum, you can say is divisible by or divides by 3. Or you could say divides evenly. We'll say it that way. I will at least. Kind of ran out of space there, didn't I? Okay, part B then. This is one of those can it, must it kind of things, right? So must this be true? No, it doesn't have to. Do you have an example? You think of one? 21. No. Because 21, well, we'll say it this way. 3 divides 21. But 21 does not have the relationship described. Above. It doesn't have a 3 digits repeating thing going on. So it would work, but it doesn't have to be true. I don't have to have these 3 digit repeats. Yes, Becca.
Would it still work if there's 3 7s, 3 5s, but then like 2 2 and 0?
It wouldn't. It wouldn't. We could do an example of it not working, because if we were to add the 2 2s together, we'd get 4, and 4 is not divisible by 3. It would also work if we just took, but it could work if we took that last 2 and we changed it to something else potentially. It just wouldn't have the same form as the one above. So part A here is sort of identifying that if it does have this particular form, it is going to be divisible by 3, and you wouldn't even have to add everything together to make it work. It's just showing an alternate feature that when it happens, you can identify it. But it doesn't have to happen for it to work, yeah. All right, if you need to write them down, here are the homework problems.